In 4.2 part 2. We're still working with our 6 trig functions, okay? But now we're going to take these 6 trig functions. We're going to take a couple of special right triangles that you learned back in geometry that you're going to relearn today, because I know you guys are going to tell me you don't remember them, okay? And then what we're going to do is we're going to create this chart. And this is a chart that moving forward in pre-calc and calc, you just have to know, okay? We're going to create it, and I'm going to show you how to create it if you know your triangles. But then other than that, you don't want to have to create the triangles and create the chart every time you need it. So it's a chart that you're going to memorize. And in fact, our quiz in this chapter will be filling in the chart by memory, okay? Or by setting up your triangles and doing it that way. But that will be our quiz in this chapter. I don't do a regular quiz. I do a fill in the chart. And that'll make more sense as we get into it. But, okay, 2 special right triangles. First triangle here is the (45, 45, 90). Do you remember any special relationships about the 45, 45, 90? Anything about the legs, the hypotenuse? No. Or we're also going to talk about the (30, 60, 90). Do you remember anything about the 30, 60, 90? Now, you're not telling me Mrs. Rogers didn't teach this stuff, right?
I remember learning it.
Okay.
But I just
don't remember the details. Okay, so in a 45, 45, 90. Obviously, I'm calling it 45, 45, 90 because those are the angles, yes? You got 2 45s and a 90. What about the legs? Guesses on the 2 legs? Equal, yes? Those 2 legs are going to be equal because they are opposite the same angle. So when we do this, we're going to represent each of those sides with an arbitrary length of 1. It's just kind of your base amount. And I'm going to write up here that legs are equal. Okay. The other piece we need to know is the hypotenuse. The hypotenuse had a special relationship in relation to the legs. Any thoughts on what the hypotenuse is? No? No? The hypotenuse is the square root of 2 times the length of a leg. Doesn't matter which leg because they're the same, right? So hypotenuse is square root of 2 times the length of the leg. So if I have these legs denoted as 1s right now, what am I going to use to represent the hypotenuse? Square root of 2. Okay, so we talk about the sides of the 45, 45, 90. They are 1, 1, and square root of 2. Okay, obviously it could be bigger numbers than that. It could be 5, 5, and 5 square root of 2. Things like that. But those are the basics. That's the 45, 45, 90. We're also going to talk about the 30, 60, 90. Anything coming back yet? No? Okay. So in the 30, 60, 90, we have what I refer to as a short leg, a long leg, and a hypotenuse. Okay, the short leg is going to be the leg opposite the 30-degree angle, and that's our base leg, so to speak. So we use a 1 there. Okay, short leg is just kind of your base amount. Your hypotenuse is twice the short leg, or in other words, 2 times the short leg. So when I write this, if my short leg is represented by 1, then the hypotenuse is double that, or it is 2. And I'm going to write up here that hypotenuse is equal to 2 times the short leg. Okay? And then we have what I refer to as the long leg. The long leg is, well, A, the one that looks longer, or B, the one that is opposite the 60 degree. And the long leg is equal to the square root of 3 times the short leg. So if my short leg is represented as 1 here, my long leg is going to be represented as square root of 3 times 1, or in other words, square root of 3. Okay? You need to know those triangles. Okay? And in fact, those triangles will be included on the quiz in terms of you have to be able to label the sides of those triangles. And that's how, if you forget anything on this chart, that's how you're going to fill in the chart. Okay? So, this chart, I just refer to it as our trig chart, has all of our basic trig information. 30 degrees, 45 degrees, and 60 degrees are 3 key angles when we start looking at the unit circle. Okay? They're all quadrant 1 angles, and they all carry important values. Now, so degrees, 30, 45, and 60 degrees. First thing I want to do, though, let's talk about what those are in radians. Thoughts on how to know what those are in radians? What did we learn to do the other day in homework? Okay. In order to go from degrees to radians, you multiply by pi over 180. So in order to change each of these degrees to radians, we're going to multiply by pi over 180. What is 30 times pi over 180? Not exactly.
I can't think of that. Pi over 6.
Pi over 6. Because if you do 30 times pi, it's 30 pi over 180. I personally say cancel the zeros. Then I have 3 over 18, and that's you just had to cancel the 0. 3 over 18, which is 1/6. And where is that 1? That 1 is technically in front of the pi, isn't it? This is 1/6 pi. We just don't usually write it that way. Okay? What about 45 degrees times pi over 180? You're going to need calculators regardless today, so I mean, essentially before you reduce it, it's going to be 45 pi over 180, but it reduces very nicely. Pi over 4. And 60 degrees. Pi over what?
Pi over 2.
Nope.
3.
Pi over 3. 60 over 180 reduces to 1/3, so pi over 3. Okay. Folks, give us a day or two, and those will just be memorization for you. You won't have to do that conversion every time, and that's the goal. Can you do the conversion if you forget? Yes, but we're just going to know these, okay? I tend to remember my 30 degrees goes with pi over 6, switch the numbers, 60 degrees goes with pi over 3, 45 goes with pi over 4, they both share the 4. Okay, I want to do the sine. Okay, this column is sine. Then we have a cosine column and a tangent column. So this first box here, I'm looking at the sine of 30 degrees, which is also the sine of pi over 6. Okay? But sine. How am I going to do the sine of 30 degrees? What do you know about sine from yesterday?
It's opposite over hypotenuse.
Okay. Opposite over hypotenuse. So the sine of 30 is
1/2.
1/2. Is SOHCAHTOA going to be a good friend to have still today? Yep. Okay. SOHCAHTOA still exists. Now, why don't we just go ahead and do everything with 30 degrees? Let's go down that column here. My brain has going across, but, across as opposed to down. Sorry. So sine of 30, opposite over hypotenuse, 1/2. Cosine of 30. What's my phrase?
Adjacent over hypotenuse.
Adjacent over hypotenuse, which is?
Square root of 3 over 2.
Square root of 3 over 2. And tangent of 30. Tangent is? Opposite over adjacent, which is 1 over square root of 3, which is helpful to know sometimes. However, I also want the rationalized version.
No, we don't.
Yes, I do.
No.
There are times you need to know the rationalized version. Do you remember how to rationalize?
Nope.
If we want to get rid of this radical in the denominator, you multiply by the radical. You multiply by itself if it's just a single radical. So what is square root of 3 times square root of 3? That's just 3, yes? If you multiply the bottom by square root of 3 or multiply the top by square root of 3, what is 1 times square root of 3? Square root of 3. So this is also square root of 3 over 3. Okay? I would say no on both, but you have to at least know one of them. Okay? I'll take either or on the quiz. Okay. Let's do the 45 next. Okay, so 45 degrees. We are switching triangles, yes?
Yeah.
Okay, sine of 45 degrees. Now, which 45 degree angle do you want to use?
The bottom.
Okay, she says the bottom one. Does it matter? It doesn't matter, does it? So if we look at 45 here, sine is what? Opposite over hypotenuse. So 1 over square root of 2, which means I want another answer to go with that.
Square root of 2 over 2.
Good. It is also square root of 2 over 2 if you rationalize it, because if it's 1 over square root of 2, we want to get rid of square root of 2, so we multiply top and bottom by square root of 2. So then you have square root of 2 over regular 2. Okay, there's your rationalizing review. Don't write it down if you don't need it. Okay, what about cosine of 45 degrees?
Adjacent over
And adjacent over hypotenuse is going to be
the same thing.
the same thing. It's 1 over square root of 2, or if we rationalize it, it's square root of 2 over 2. And tangent of 45.
Opposite over adjacent.
Opposite over adjacent,
1,
1 over 1, which is 1. Best one yet, right? Okay, one more row. 60 degree row. Sine of 60 degrees. So now we're using the 60 degree angle up here. That's your angle you're starting from. So sine of 60 degrees means we're going what? Opposite over hypotenuse. So we want square root of 3 over 2. Cosine of 60. Cosine says we do
1 over 2.
adjacent over hypotenuse, 1/2. And tangent of 60? Tangent of 60 says opposite over hypotenuse, square root of 3 over 1, or in other words, square root of 3. Okay. I encourage you to just memorize this chart. However, I know that's going to take some time. Can you always go back and make the chart if you have the triangles memorized? Most definitely. You'll notice some connections. For instance, sine of 30 is the same thing as cosine of 60. Cosine of 30 is the same thing as sine of 60. We know our 45 sine and cosine are the same. These tangents of 30 and 60 are reciprocals of each other. There are definitely some connections you can use there. Okay? This chart is going to be helpful in homework, and I'll talk about how here in a moment. But I want to do the next chart before we do that. Okay? Now, you guys have the advantage, you have the charts right beside each other, yes? The way my notes worked out, I'm hopping to the next page. Good thing I hope I know this stuff. Now, in this chart, it asks us to find the cotangent, secant, and cosecant of each of the three angles from above. Notice my degrees are the same, 30 degrees, 45 degrees, and 60 degrees. There's still a radian column. You know what your radians are? What was it for 30 degrees? Look above. Pi over 6. 45 degrees, the radians are pi over 4. And 60 degrees, the radians are pi over 3. Now, I didn't label these columns. You can label them how you want. I have in my mind how I'd like to label them.
Please show.
What do you have in the chart up above?
Sine, cosine, tangent.
So what would it make sense to do in this chart down below? Cosecant, secant, cotangent. And why is she picking that order? Those are the reciprocals, yes? So sine was up above. The reciprocal of sine is cosecant. So I'm going to make this first column cosecant. Cosine was second up above. Secant is its reciprocal. So I'm going to make this column secant. And tangent was up above. The reciprocal of tangent is cotangent. So I'm going to make this column cotangent. Now, you have an option. We can go back to the triangles to fill these in. Waste of time if you ask me. What's easier than going back to the triangles? Doing the reciprocals, yes? So when I say cosecant of 30, well, what was the sine of 30? Sine of 30 was 1/2. So what's the cosecant of 30? 2. Okay. Which way do you want to go?
Down.
You want to go down? Cosecant of 45.
Square root of 2.
Okay. It's the reciprocal of 1 over square root of 2, which becomes square root of 2. This is where it's good to have both of those in that box up above. Because one of them, we don't want to say it's the reciprocal of 2 over, or do 2 over square root of 2, because then you have to rationalize. Bottom row. Cosecant of 60. What's the reciprocal of sine of 60?
Square root of 3 over 2.
So the reciprocal of square root of 3 over 2 is going to be 2 over the square root of 3. We do need to rationalize. So what do we multiply by to rationalize? We're multiplying by square root of 3. So you're going to have 2 times square root of 3 over square root of 3 times 3 is, or square root of 3 times itself is 3. Okay, secant column. Secant of 30, we're flipping the square root of 3 over 2 again. So what are we going to have? 2 over square root of 3, or 2 square root of 3 over 3. Secant of 45? It's going to be the same as cosecant of 45, yes? It's the reciprocal of 1 over square root of 2, so it's square root of 2. Secant of 60. Reciprocal of 1/2, so it's 2. Notice there's still some matching boxes, just like there was up above, right? Okay, cotangent of 30. That one is the one that's the reciprocal of 1 over square root of 3, so we're going to have square root of 3, my favorite. Cotangent of 45. Reciprocal of 1 is 1. And cotangent of 60. This is the reciprocal of square root of 3, so 1 over square root of 3, or look up above. What was that rationalized? Square root of 3 over 3. We already did that up above, didn't we? Okay. Your mid-chapter quiz is going to be what we've just done today. Okay. At some point, I don't have it scheduled yet, but we'll have the 2 triangles to fill in, and then this will just be one big chart with all 6 trig functions on it and radians. You can memorize it. You can learn your triangles and fill it all in based on the triangles, however you want to go. Okay? Now, if I recall correctly, there's 3 sections in homework. 2 of the 3 sections in homework, and we're getting ready to do the bottom section, don't worry. But 2 of the 3 sections in homework, you're just going to be using this chart. Okay? So, for instance, 19 says evaluate without using a calculator. Let me give you a free homework answer. Okay? 19 in homework, and you just write it on the side of your notes, ask for the sine of pi over 3. So, folks, the sine of pi over 3 says we go to our chart. I'm going to have to flip pages, aren't I? We find pi over 3. Where's pi over 3? There's pi over 3, right? So them saying sine of pi over 3 or sine of 60 is the same thing. What is the sine of pi over 3 or 60? It is square root of 3 over 2. Your answer to that problem with no calculator, with no work, is square root of 3 over 2. That's all they want on that problem. Easy enough?
Yeah.
No, when it says without a calculator, I'm looking for that type of answer straight from the chart. That's what you're doing on 19 through 24. Okay, 29 through 40 is the calculator section. We're getting to that. 41 to 48. Find the acute angle theta that satisfies the given equation. Give theta in both degrees and radians. You should do these without a calculator. So, 41. Here's your other free answer. It says sine of theta equals 1/2. Okay? They want to know what theta is. Go to your chart. So where do we find sine and 1/2 in our chart? Here's sine, here's 1/2. When does sine and 1/2 occur? At what angle? At 30 degrees, which is also how many radians? Pi over 6. So the answers they want are 30 degrees or pi over 6. It said to answer in radians and degrees. So you're giving both answers. That's how you do those 2 sections. This homework's going to go quick, isn't it? Okay? No calculator. You give me a calculator answer, I'm going to know you didn't do it right. Because you're going to have decimals and stuff. Now, ready for the last section? Evaluate each of the following on a calculator. So you need your calculators out. I would encourage you to make sure you know how to do this on the graphing calculator. However, you did this in geometry on a scientific calculator probably. Okay? So, sorry, there's lots of craziness going on here. Sine of 15 degrees.
Is there a degree symbol?
Nope.
Okay, so it's just sine of 15.
It's just sine of 15. Okay, did you get it? What are you guys getting?
0.6502.
What'd you say?
0.6502878412.
Yeah. Are we all getting the same answer?
Yeah.
Is that my answer?
No.
Is that the exact same answer? I didn't catch what you guys said. No. Notice the note here. It says be sure to make sure you are in the correct mode. 15 degrees means you need to be in what mode? We need to be in degree mode because 15 is degrees. Notice, what does my calculator say up top? I was sly. I switched it. It says degrees. Does your calculator say degrees at the top? Because if so, you have the right answer, probably. What does your calculator say in that position?
Radian.
Probably says radian. So, find your mode button, which is right next to the top, the second button. So, hit mode, and the fourth row down is radian or degrees. You're going to become very friendly with that. You're going to want to go to degrees, hit enter.
There it is.
You can clear out of that, redo sine of 15, and you'll get a different answer.
Why?
Is your answer matching mine now? This is going to be the most frustrating part about this lesson. You have to remember to switch your mode back and forth. Okay? So, I do not have rounding directions on the screen, do I? In my notes, I have it to 3 decimal places. So what is this to 3 decimal places?
259.
0.259. Okay. Cosine of 5 pi over 7.
Wait, are they all in degree?
Are they?
This one's a degree.
What is 5 pi over 7? Does it have a degree bubble? There's your clue. Does it have a degree bubble? No. So what is it?
It's a radian.
It's a radian. So what do you need to do on your calculator? Go to mode, switch back. Now, the nice thing is, it tells you on the top of your screen what mode you're in, doesn't it? So now, if you've switched to the correct mode, which this one we need to be in radian mode. Yep, you can have negatives. We'll talk more on another day about which quadrants are negative or positive when. Okay. So, cosine of 5 pi over 7 is negative 0.623. Are we getting these?
Yeah.
Please let me help you with your calculator if you're not. Okay? It's easy. But if you're not getting it, let me point you in the right direction. Okay? Okay, C. Tangent of 57 degrees, 13 minutes, 15 seconds.
Which mode?
Well, what mode are we going to have to be in? This is, I see a degree bubble, so we're going to need to be in degree mode. What's the other catch here? Right now it's DMS. Remember degree minute second mode? We don't have a degree minute second mode option.
Do we have to switch it?
So we have to switch it. Okay? So you're switching this. So this is lesson 4.1, the very first thing we did this week. This chapter, right? No, very first thing we did Tuesday, because Monday we took a test.
Yeah.
Okay, so 57 degrees is your whole degrees. How do you change minutes to degrees? 13 divided by the 60. Plus, how do we change 15 seconds to degrees?
16.
You're dividing by 60 squared or 3600. Sound familiar? Now, there's a couple of different ways you can do this. Okay? You can go ahead and put this in on the calculator and come up with this number. So right there, gosh darn it. Okay. It gave me a fraction answer. Do I really want that as a fraction? No. You know you can go into math menu and go to number 1 where it says fraction. And it'll, not number 1. I don't want to change it to a fraction. It's already a fraction. I want to change it to a decimal, so I'm going to go to number 2. Gosh, that's straight right if we're going to demonstrate. Okay, so this is the 57.220, so on and so forth. Here's what I would do. You're on a fancy calculator that allows you to arrow up and down and copy and paste, yes? I wouldn't just type in this short number. I would type in the whole number when you do it. Or copy and paste it. Now, with this in mind, what are we doing here? Tangent. You can either do one of two things. You could arrow up and get that 57 number right there. Or another option you can do, folks, could we have just typed that whole thing right there into tangent? Do we even have to know what that actual degree is?
I don't know, can you press the
You had to see for facts, didn't you? Okay, so that's an option there. Okay, so when you do this, you're doing the tangent of that 57.220 whatever number. Did you switch your mode? If you didn't switch to degree mode, you're not getting the same answer as me, are you? And we get 1.553. Your homework must say it around to 3 decimal places if that's what I'm doing. Okay. Got it?
Not the next one.
You don't have the next one? What's wrong with the next row?
I don't have a.
Do we have a cotangent button?
No.
No, we don't. We do not have a cotangent button. However, what do we know about cotangent? It's a reciprocal of tangent. Okay, now, let me ask first before I go too far. What mode are we going to be in?
Radian.
Negative pi over 10 does not have a degree bubble. That's radian, so we are going to be in radian mode. In order to do cotangent, you do not have a cotangent button. So you're going to do the reciprocal of tangent of the negative pi over 10. Now, when I say that, did I write this? Okay. Now, there's a right way and a very wrong way to do this, okay? In order to do the reciprocal, okay, first of all, you cannot use the tan -1 button. That will get you a wrong answer, okay? So I know the common thing is, oh, hey, there's tan -1. That's inverse. That's not reciprocal. It's different. We'll learn that another day, okay? So what we're going to do is I'm going to go ahead and do regular tangent of negative pi over 10. And then I'm going to raise that to the -1 power. You can raise that to the -1 power using your exponent button or right above your x squared button. You have an x -1 button, don't you? That will raise it to the -1 power or put, it's the reciprocal there. So we're doing tangent negative pi over 2 or negative pi over 10 raised to -1. What mode am I supposed to be in?
Oh no.
I need to be in radian mode. If your answer matches my answer, you might have done everything right. The O note tells me you were probably in the wrong mode. So, negative 3.077. Nope. 78. If I round appropriately. Okay, we getting it? Okay, E. What can you tell me about E?
Degree mode.
Okay. Did I make you go back and forth on purpose? Maybe. But will homework make you go back and forth? They do. What do we know about secant?
Cosine.
Secant is reciprocal of cosine. So we're going to do the cosine of 87.36 degrees raised to the negative 1 power. So that's the reciprocal. Raising to the negative 1 power, flips it upside down, it's the reciprocal. Cosine 7.36, no degree bubble necessary, raised to the negative 1. Did you get my answer? 21.711 if you round it. And lastly, what mode are we going to need? This is going to be a degree mode again, isn't it? What function am I doing? Cosecant is reciprocal of sine. So if you want, you can do this sine of, it's 7 degrees, plus 10 minutes is 10 over 60 degrees, plus 18 seconds is 18 seconds over 60 squared. And then raise to the negative 1. If you would rather type that in first and come up with a number, that's fine as well. I have that 7 degrees, 10 minutes, 18 seconds is 7.1716, so on and so forth. So either way, you can make this work. What are we doing? I'm going to do sine of 7 plus 10 over 60 plus, okay, I don't know what I hit there, but I hit something wrong. Sine of 7 plus 10 over 60 plus 18 over 60 squared. Right there it's going to do sine. If I hit negative 1, it's going to do cosecant. Does your answer match my answer? 8.010. Okay. That lesson took longer than I remember it. I don't remember it taking a whole period. What the heck? Okay. Well, almost a whole period. Now, the middle section of homework. So it was like 29 to like 39 or something, 29 to 40, something like that, is going to be doing this. So grab your calculator, use your calculator. The first section and the third section do not use calculator. I'll know by looking at your answers if you use the calculator. The first and third sections of homework, use your charts. Okay? Homework 19 through 24, 29 to 48.